Okay, this is the 2025 free response questions for the AP Calculus AB exam. I'm going to be doing number 4, and I just want to note that not only was this on the AB exam, this was also number 4 on the BC one as well. So number 4 says the continuous function f is defined on the closed interval -6 less than or equal to x less than or equal to 12. The graph of f consisting of 2 semicircles and 1 line segment is shown in the figure. Let g be the function defined by g of x is equal to the integral of 6 to x f of t dt. Part A says find g prime of 8, give a reason for your answer. Okay, so for A, based off what the g function is equal to the integral of f of t, which tells me if I was to take the derivative of the g function, then I would get the derivative of g of x is just equal to f of x. Which means if I'm trying to find g prime of 8, I just need to find f of 8. And if I go to my graph above, f of 8, here my value will be 1. Okay. Part B says find all the values of x in the open interval at which the graph of g has a point of inflection. Give a reason for your answer. So for part B, I'm just going to look at the graph, and I know that the point of inflection is where on our graph of f, all the values are going to be where we start changing directions. Okay, so for example, we are going to change directions right here at -3. Okay, so notice we're going negative, and then we're going up positive, change in direction, so that's an inflection point. Our next one is going to be at 3. Again, this is going up positive, and now it's going down negative, a change in direction. And then lastly at 6, where we're going down negative and then up positive, are going to be my inflection points. So for B, I'm going to write when f of x changes direction, or in other words, slope, that's where I'm going to find my inflection values of x equals -3, 3, and 6. Part C says find g of 12 and g of 0, label your answers. Okay, well, g of 12 is going to be the integral of 6 to 12 f of x dx. And if we look at 6 to 12, so we're finding the area. Okay, so if I look from 6 to 12, notice that from 6 to 12, I have a triangle. So I'm trying to find this area here. Well, we know that the area of a triangle is equal to 1/2 base times height. So I'm going to use that with a base of 6 and a height of 3. Okay, so going back to my answer here, this is going to be equal to 1/2 base times height, which is equal to 1/2 times 6 times 3, which is equal to 9. So g of 12 equals 9. And then g of 0 is equal to the integral of 6 to 0 f of x dx. So from 6 to 0 here, notice that that's right here, okay? But we want to go from left to right, so instead of writing 6 to 0, I'm going to flip it and just change my integral negative. That way I have negative integral of 0 to 6 f of x dx. Okay, then I'm going to go up here and notice that I'm trying to find the area of this right here. And we know that this is made of semicircles. And we know that the area of a circle is pi r squared, where the radius here would be 3, but it's only half a circle, so we're only going to do half of that area. So plugging that in here, we get this is equal to negative integral of 0 to 6. Actually, no, I don't have to rewrite that. Equals negative 1/2 pi of r squared, which is equal to negative 1/2 pi of 3 squared, which is equal to negative 9 pi halves. Part D says find the value of x at which g attains an absolute minimum on the closed interval and justify your answer. Okay, well, from here, what we're going to do is we are going to look at that interval. So I'm going to go back up to here, and I am going to find where f of x is equal to 0. Well, I know that f of x is equal to 0 all the points that it crosses the x-axis. So at negative 6, 0, and 6 are going to be when f of x is equal to 0. So going down here, so f of x equals 0 implies that x is equal to negative 6, 0, and 6. And I'm going to find all of those values. Well, we're going to find all of that values for g. So g of 0, we already found in the previous problem, is equal to negative 9 pi halves. And then g of negative 6 is equal to the integral of 6 to negative 6 f of x dx, which we know is just going to be 0. And then the value of g of 6 equal to the integral of 6 to 6 of f of x dx is also just going to be 0, which means that the negative 9 pi halves is our smaller value. So negative 9 pi halves is the minimum at x equals 0.